Okay, the next video, we're going to find the distance from a point, -6, 3, comma 5, to the plane x minus 2, y minus 4z equals 8. Again, this is another one of those sort of critical problems that I have no problem telling you this is going to be on your test. Okay, this is almost on every, this might even be on every test because, not every test, but because there's so many different ways to do this problem, I like coming back to it. So we will definitely come back to this problem. And we will do this now. Okay, so let's start just with this example and I'm gonna show you how to generalize it, okay? So with this example, what we're gonna do, what we have is we have a point, okay, let's call it, well, -6. 3, comma 5, and we have a plane over here. Okay, and our plane here is defined by, I don't like how my plane came out. Okay, that'll have to do. And my plane, let's make it a little bigger, is defined by the equation x minus 2y minus 4z equals 8. Okay, now we have the distance from the point to the plane. You have to take the smallest distance, right? So you're going to have a point somewhere on this plane that meets with this line. Now, how do I know what this line is? Well, remember, shortest distance between any 2 points is a straight line. Okay, so the shortest distance is actually going to be the perpendicular distance. Okay, so what does that tell us? What does that tell us about the equation of this line? Well, that means the equation of the line of intersection is x of t is -6 plus t, y of t is 3 minus 2t, z of t is 5 minus 4t. How did I get that? Remember the normal vector to the plane, okay, the normal vector to the plane here is 1, -2, -4. It's just given by the coefficients of the x, y, and z here. Okay. Man, I don't like my 5s. There we go. Okay. So now we've got to find out when does this line intersect the plane. Okay, so when does the line intersect the plane? So that means we're going to have x of t minus 2y of t minus 4z of t equals 8. Okay, so we're just going to have the line satisfying the equation of the plane. Okay, so just plug that in. So we're going to have -6 plus t minus 2, 3 minus 2t minus 4, 5 minus 4t, that should all equal 8. Okay, so let's solve for t. So that means we're going to have -6 minus 12 minus 20, so minus 26. Okay, how many t's are we going to have? T plus 4t is 5t, plus 16t is 21t. Okay, equals 8. 21t equals, let me just make sure I feel like I messed something up. -6, -12. I did. -6, -6, -12. Minus 20, that's minus 32. I just knew because I knew the answer from before. So 21t is 40. So t is 40 over 21. Okay, that's the time. Now, here we're gonna have to do a little bit of trickery, okay? Not trickery, but just a little bit of thought, all right? So let's say that I am here and I move with this sort of velocity. Let's think of it as velocity. After 1 second, I have moved along that vector 1 time. Okay, so I'm going to take this magnitude of n, which is going to be, or which is 16 plus 4 is 20, 21, square root of 21. Okay, and that's how far I move each second. Okay, that's how far we move each second. Actually, let me move that over here. Okay, so if I go 40 over 21 seconds, and each second I move a square root of 21, then my distance is 40 over 21 times the square root of 21, which is 40 over root 21. Okay, so this is actually the final answer. Either way is fine. I'm not really super concerned. Okay, but that's the final answer. Now let's do this in general. Okay. And by in general, I mean we're going to come up with a nice formula, because that formula actually does exist in your book. I think they write it like this. We're going to find the distance from x1, y1, z1 to ax plus by plus cz minus d equals 0. Actually, I think it's plus d equals 0. Okay, so that's how they write that's how they set up the formula in the book. Okay, so let's go ahead and do that. All right, so same exact process. All right, we have a point. Now we're going to give it a name. x1, y1, z1. We have a plane over here. Okay. There's a point at which the line intersects. We need that to be perpendicular. Okay, otherwise it's going to be not as, it's not going to be the closest point, right? Okay, so that means that this vector here, the normal vector to the plane is ABC. Okay, again, we're going to ask, when does it intersect the plane? So our line connecting the point to the plane Now, it's not the only line, but it's the minimal line. All right, the one that's going to give us the minimum distance, okay, is going to be x1 plus at, y1 plus bt, z1 plus ct. Okay, so this is the line. Of course, x of t, y of t, z of t. Okay, and now we're going to connect it to the plane. So we're going to take a times x of t plus b times y of t plus c times z of t plus d, well, let's put it equals negative d. Okay, now we're going to solve for t. So this is, of course, when does the plane intersect, or when does the line intersect the plane? Okay, solve for t. So we're going to get ax1 plus by1 plus cz1. Let's put plus d here again. Okay. Plus, now we're going to have t times a squared plus b squared plus c squared equals 0. Okay, so we're going to have to find that t. Okay, so t is ax1 plus by1 plus cz1 plus d divided by, that's going to have a negative, a squared plus b squared plus c squared. Okay, now we're going to go ahead to find the distance. Remember, we're going to have to travel distance traveled along the line per second is the square root of a squared plus b squared plus c squared. Okay, so our distance, our final distance is going to be, we use a magnet's absolute value here. That negative should have been in front of everything. We use an absolute value just so that we make sure we always get a positive. ax1 plus by1 plus cz1 plus d divided by the square roots of a squared plus b squared plus c squared. Okay, and if you look at the other problem we did, then you'll see it actually follows that exact formula. Okay, so now this formula, normally you're actually out of luck that you're doing this online. Why? Normally I would go ahead and be like, whatever, just use the formula. But because we're doing this online, and the way that I'm going to be testing you, I'm actually going to be testing you. I'm going to ask you different questions about the problems when I give them to you. So yes, you could get the answer, but you might not get all the parts. I might ask you, is part of solving this problem, let's say I gave you this problem, I might say, well, what is the equation of the line? And you'd have to tell me that. And then, when does the line intersect the plane? What is the t value for which it intersects the plane? So I could ask you all of that. Okay? All right. I will see you all. That's it for 10.5, I believe. But I'll see you all in the next video.